Greetings, this is Mr. Garwood with his video series on calculus from the second edition calculus textbook by Briggs, Cochrane, and Gillette. Today we're going to focus on the definition of limits. We're going to spend much of our time looking at figure 2.7 found on page 44 of the text, and then we're going to look at figure 2.13 as well. Our big takeaway today is what is a limit of a function at a particular point and how do we find it and what are the requirements for it to exist. We're going to look at figure 2.7 in a couple instances. We're going to start by considering what is going on when x is 1. From your algebra in high school, I trust that you understand that when x is 1, we can talk about what is the function output at 1. A lot of times that we could consider that to be the y coordinate. But in this instance, let's figure out what that is. We can simply take our, I've got a ruler here and I'm just going to go up and mark just a little dotted line starting from the x-axis and moving up until I find where I touch the function. Okay? That happens to occur here when the y coordinate is 2. Now, this is kind of where algebra stops and we start discussing the ideas in calculus of a limit. Well, what a limit does is a limit allows me to talk about what is the function doing around 1. What is in this area, what is the function doing? We can talk about as the function moves from the left, and we can also talk about what the function is doing as it comes from the right. Well, I like to do that just by, so when I say from the left, what is this doing as I get close to 1 from the left? And what is this doing as I'm getting close to x from the right? We also could talk about, as I go from the left over here, it looks like I'm increasing. And as I come over here from the right, things are decreasing. But the big take I want to work on is, well, what is this function doing? So I'm going to kind of just lay this green marker across and look at, well, the function is doing this in that area. Well, where's it going? Well, we denote the limit of a function by saying the limit as x goes to some point. In this case, we're talking about 1. And we put a superscript negative sign to denote that we're coming from the left. Now we see, well, in this ballpark, we're increasing and we get really close to 2. So we can say that the limit as x goes to 1 from the left is 2. By a very similar argument, use my blue pen, we can look at what the function is doing. Well, we can say the limit as x goes to 1 from the right, so with a plus sign instead of a minus sign. What is it doing as things go from the right? Well, it too goes to 2. And we're not concerned about things going on all over the place. What we're really focusing on is right here in this neighborhood around 1, what's the function doing as it gets close to 1 from the left and from the right? Well, we notice here these two are the same. And that's actually a really important thing, because instead of just talking about from the left and from the right, if we satisfy this condition, if the limit from the left is exactly the same as the limit from the right, which we can see here in both instances is 2, then we can say that the limit as x goes to 1, and notice I don't have anything else there, just the limit as x goes to 1 is that number. So, if this is true, then the limit at that point exists. Here, also I want to note, look, the limit from the left, the limit from the right, the limit at that point are all the same, and they are all exactly the same as the function value. This does not need to be true for this to be true. So considering that, let's look at exactly the same picture, except this time instead of talking about what's going on when x is 1, we're going to instead talk about when x is 2. So here I'm going to evaluate f of 2, looking at that y coordinate. Well, I'm going to follow it up, and notice here there's a gap in our function, and this is not the function value. Instead, our function value here is 5. Okay? Now we talked about, when we talk about coming from the left, and then again, what's the function doing as we come to 2 from the right? Just as before, as we come from the left, the y values are increasing. They seem to be getting very close to 3. So we can say that the limit, as x goes to 2 from the left, is 3. And as we come from the right, well, from the right, we're decreasing, and similarly as before, we can say that the limit as x goes to 2 from the right is also 3. Okay, well, let's check to see if there is a limit at 2. Can we say that the limit from the left is the same as the limit of the right? Again, we can. So we assert that the limit at x goes to 2 from the left is exactly the same as the limit as x goes to 2 from the right, which again here in both instances is 3. Well, both of those are the same, so just as we did before, we can say the limit as x goes to 2 with no other conditions is precisely 3. So, but wait, the limit is 3. It's converging to here, but that's not the function value, and that's okay. Just because the limit and the function value are not the same does not cause any problems. Our definitions say it's converging to 3. We talk about converging, it's getting very close to. Does not matter that these two are different. That is okay. Now, I want to look at an example that's very similar, but a little different. Here's figure 2.13. This is found on page 47 of your text. We're going to do exactly the same thing. So we're going to look at here, as you might be able to guess from looking at it, we're going to look again at what happens when x is 2. Well, just like we did before, I'm going to lay down my ruler and I'm going to mark up and see, all right, well, when I'm at 2, the function value here is 1. So we'll say f sub 2 is 1. Okay. Now, we're going to look at from the left. From the left, the function is way up here, and we're decreasing down, and it looks like we're going to 4. So So that we could say the limit x goes to 2 from the left of the function is 4. Okay, now got to mark we're going to 2 from the left. Now we also can say limit as f goes to 2 from the right. Well, it's actually staying pretty constant here, and it's converging to 1. So I've got the limit x goes to 2 from the right of our function is 1. Now, for this limit to exist without condition, we said that the limit from the left and the limit from the right must be the same. Well, the problem here is 4 and 1 are not equal, which means this is not equal. Now, what does that mean? Before, we said that if the limit from the left and the limit from the right were the same, then the limit as the function goes to that value is that number. Well, they don't do that. What we're going to have to say then is that the limit as x goes to 2 of this function does not exist. It's not there. And that's okay. It seems a little weird for us to say that there's a limit from the left and there's a limit from the right, but there's not an actual limit there. And that's because these two limits, this one's way up here, this one's way down here, and they're not at any point getting together so they get to the same point. Thank you for taking your time to watch this. I hope you found it useful. Have a good day.